Hello guys, welcome back to another lecture in this course. In this video, we shall be looking into Scikit-Learn library. So we are going to look into a dataset called iris. In this dataset, it contains 4 features or variables, and these features are length, width, and in terms of petal and sepals. These variables are samples of 3 species of iris, which are iris setosa, virginica, and iris versicolor. The main objective is to create a linear discriminant model to classify the species. So the dataset is used for data mining and classification or clustering. So what we need to do first, we are going to look for this dataset in Seaborn. So we have a module called Seaborn. In Seaborn, we have a dataset called iris there. So to use Seaborn, we need to import Seaborn as CBN. So Seaborn here dot load the dataset. Then we pass the dataset that we want to load here as a parameter. Then we print to visualize the dataset here. So let us run our code. Right, after running our code, you can actually see that we have the 150 rows and 5 columns. And we can actually say that we have 150 observations and 5 features. And these features are variables. So we have sepal length, sepal width, petal length, and petal width. And these are species that we said we have setosa, virginica, and versicolor. So now what we can do also, we can convert this data to a data frame by using pandas. We can represent this same data in a pandas data frame, as you can see here. So we can put this data in a table. So as we can see here, we can actually see that the sepal length, we have 5,1 centimeter, 3.5 centimeter on sepal width. So these all measurements are in centimeters. So if you want to see only 5 rows of our data, you just put H5. Or if you want to get a detailed information on our data, you just say dataframe.info, where our data frame here we have passed it as a variable right here. So we can actually say that a brief information of our data set, we have 150 entries, meaning 150 observations of length, width, of sepal and petal. And also in index, we have index 0 up to 149. And the columns, the data columns, which is the features or which is the variables, we have 5. And these variables, they can be seen by index 0 up to index 4, as you can see here. And also they have the entries, which is 150 observation for each feature. Now let us dive into Scikit-Learn. The Scikit-Learn module, it comes automatically with the iris dataset here. So what you need to do is to call the Scikit-Learn module dot the dataset module, then load the iris. So if we run this line of code, it means we'll be able to visualize our dataset. So we can actually see that the dataset now, it has been well arranged in terms of a dictionary. So this is our key in the dictionary. This is our key, which is data. And the data is having an array of values, where in our pandas data frame here, we were saying that the sepal length index 0, we're having 5.1 centimeter, sepal width 3.5 centimeter. So we are actually only collecting these 4 elements, and we are placing them in our dataset as 4 columns. So we can actually see here, we are having, this is the first row with this observation, followed by the second row, third row, up to 150 entries. So this is how they collected the data. So now the key is saying this is our data with the following data recordings or data entries. So now, after collecting this data, we have what we call a target. If we are to scroll down here, we have another key called target, and our target is the species here, because the main objective on our iris data set, we need to classify the flowers in terms of its in order of their species. Either is it setosa, is it virginica, or is it versicolor. So these species are our target. So we need to classify this data to match either on setosa, virginica, or versicolor. So these species, we are going to call them our target. As you can see here on the data set, we have a key called target, and the value in arrays we have 0, 0, 0, and 1 and 2. So it means the target is in the form of 0, 1, and 2. So our data is going to be analyzed, and the prediction is either going to become as 1 or as 2 or as 3. So if the data is grouped together, or if the data is nearby which fit in on a setosa, it means it is 0. If it is fitting on virginica, then it means either it's 1 or versicolor 2. And also we can actually say that the target names in array is setosa, versicolor, and virginica. And if you are to scroll downward, we can see actually that the features name or our variables are sepal length, sepal width, petal length, and petal width. And the file name is iris.csv, and the iris file is the file that also we have fetched from Seaborn. So there are a lot of ways to get this data. Now, so this is a brief overview or a brief explanation on what is going on our data set. So we have the target variable, and the target variable has 3 classes, which are setosa, versicolor, and virginica. So the data represents the features which are variable. That helps the model learn how to predict it. So this is the data which has 150 data points, and in each of the 4 groups of data in the array. Because the data in the array, it is having 4 groups. This is our first group of sepal length, sepal width, petal length, and petal width. So everything is measured in centimeters. So let us take a look into our features or variables or matrix. So we can call it matrix X, and our dependent variable or the vector response Y. So we can actually see that our target data, which is this, the measurements, these ones, the sepal length and the sepal width, we are calling them X. Okay, we are calling them X. So iris.data, we are storing it in X, which is our, this one, X. We can call it, this is independent variable. This is an independent variable, and our dependent variable, which is Y, our target. This is our dependent variable, our target, and our target is either setosa or versicolor or virginica. So now, how are we going to classify our data or to make analysis? We are going to use Scikit-Learn. We are going to use model selection, and this model selection, we need to fit the data. Okay, so here from Scikit-Learn, we need to import the model selection, and remember we have X as independent feature and Y as our dependent feature or variable. So we are training our data as X train, and also we need to test the data X test. Same applies to our Y. We need to train a sample of data, and we need also to test that sample of data that we have trained here, which is equals to model selection, this one. And what we need there is to call our train test split. So our train test split is going to train the data here, and it's going to train 75% of our data. It's going to train only 75% of our data. So we are going to train and test it there. So what we need also to do, we are going also to import k neighbors classifier. So what happens with k neighbor classifier? It is just a supervised learning algorithm, and this supervised learning algorithm, what it does, it classify data based on the neighbors, especially the data which is nearby. So what we need to do now, we need to classify our data. So to classify our data, we call our k neighbor classifier, which we have imported here. And now we need to classify it into three groups, depending with the nature of the data we are having. And now we need to fit the data in our parameters, so that the data will not overfit. So that we need to check. So we need to check our data. We need to fit our data there. So we classify this data that we have classified it into neighbors and into three classes. So classify.fit xtrain and ytrain, the data which have been trained. So let us run our line of code here, and let us run our line of code again there. So after checking the nearby data, we collect the result and classify accordingly, either to setosa, versicolor, or virginica. So this neighbor classifier, it classifies based on either these three: setosa, virginica, or versicolor. So now what we need to do is to test the data, because we have trained here. We have trained by classifying it. After training the data, now we need to test the data here. So our classifier.score, we need to test. So we can actually see that we have 0.9736841. So this means that the model correctly classified 97.36% of the data. And this is a very good score, indicating that the model is likely to be very accurate in predicting the labels of the new data. So this is the basic overview on how we use Scikit-Learn in the machine learning algorithm. Thank you for watching. See you on the next lesson. Bye bye.